Okay, so graphing parabolas from vertex form. Okay, so vertex form is y equals ax minus h all squared plus k. All right, so from this form we can get the vertex right away, and we'll see some stuff about factored form too. So in here, in this form, we get the vertex of the parabola is at the point hk. Right, so we have a minus there so that we can take the x coordinate directly. So hk is the vertex. It's been horizontally translated by k, vertically translated by x, from y equals x squared. Okay, so a is the stretch factor, as it has been in every form. Okay, and its sign will determine which way it opens. The y-intercept can be determined by setting x equal to 0 again and solving for y. The x-intercepts can be determined by setting y equal to 0 and solving. Okay, and there's a couple ways of doing that, as been shown before. Okay, so let's take a look at the first example, y equals 2x squared. And I'll just expand this here so it's easily seen. Okay, sorry for the bouncy camera. So y equals 2x squared, well, that's, if you look at y equals x squared here, okay, so it's this one where every y value has been doubled, so in that table of values. Okay, so basically, if this is y equals x squared, the blue one here, it goes over 1, up 1, over 2, up 4, then y equals 2x squared is going to go over 1, up 2, double that. Over 2, up 8. 8 is double 4. Okay, so the y equals 2x squared is the black one here. Y equals 1/2 x squared. Well, same idea, but it's going to go up less fast. So y equals x squared would be going up faster, 2 and 4. So y equals x squared would look like this blue one here. Okay, so the blue one is y equals x squared, and y equals 1/2 x squared would be compressed. Okay. So that is the effect of a vertical stretch. Now, vertical stretch with negatives, like this one, y equals negative x squared, well, it's the same thing. Vertex is 0, 0, and it opens down. Okay, so all the y values are then negative instead of positive. Negative 3x squared is the same idea, but it's been vertically stretched by factor 3. So it opens down, but as you go over 1, instead of going down 1, you go down 3. If you went over 2, instead of down 4, you go down 12. 3 times 4 is 12, and I can't show you that on this graph. Okay, so we can only roughly draw that. Now, the horizontal translations, something like y equals x minus 2 squared. Well, in this one, the vertex is going to be at x equal to 2. It's been horizontally translated 2 to the right, and it has not been translated up or down at all. So the vertex is 2, 0. Y-intercept is negative 2 squared, because you sub in x equal to 0 there. Square it, and you get 4. So the y-intercept is 4. So it's been moved to the right 2, and the y-intercept is now 4. And if we graph that, it looks like this. Okay, so from the vertex, which is 2, 0, you go over 1, up 1. It has not had a vertical stretch. Okay, because the a value here is just 1. So you go over 1, up 1. Both ways. Over 2, up 4. And so on. Okay? Now what about y equals x plus 3 squared. Well, for this one, it's been horizontally translated to the left 3. So the opposite of that sign. The vertex is at negative 3, 0. Y-intercept, plug 0 in for x. We get 3 squared, which is 9. Okay? And the graph then looks like this. And I can't show you the y-intercept on here because the graph only goes up to 6. Okay? So over 1, up 1, over 2, up 4. Same pattern. No vertical stretch. No change in the shape from y equals x squared. So now, if we look at vertical translations, y equals x squared plus 1, well, this one, it has no horizontal translation because there's nothing in brackets there, but it's gone up 1. So the vertex is now 0, 1. From y equals x squared, it's been translated up 1. Okay? And this is the graph that we get. You can't get x-intercepts from this because it doesn't cross the x-axis. So if you tried to solve for x when y equals 0, you would get nothing. You would get the square root of a negative 1, which does not exist. Okay, so there are no x-intercepts sometimes. So sometimes you cannot put it in factored form. There is no factored form for this parabola. Okay. So another one is y equals x squared minus 3. Now this one has been translated down. Still opens up, but translated down. So for this one, you've got the vertex is negative 3, and you can get some x-intercepts. Set y equal to 0, bring the 3 over, or write it this way, and then x must equal plus or minus the square root of 3. Okay? And here's what the graph would look like. Okay, so here is the vertex at negative 0, negative 3. Go over 1, up 1. Over 2, up 4. Put us there. So it's kind of hard to see exactly what the x-intercept would be from this one. But in fact, it is root 3. And this x-intercept here is negative root 3. For this one here, y equals 2 times, this is all of them together now. Okay, so we've got a vertical stretch, horizontal translation, and a vertical translation. Okay, so the vertex now is 1, 3. Y-intercept, plug in 0 for x. You need the y-intercept of 5. And because it opens up and the vertex is above the x-axis, there are no x-intercepts for this one. Okay? So that's basically what it would look like. Vertical stretch factor of 2. So from the vertex, you go over 1, up 2, over 2, up 8, which I can't show on this graph. So you just do the first one. Happens to go through the y-intercept here of 5. Okay? Next one is y equals negative 3, x plus 2 squared minus 1. Well, vertex is negative 2, opposite side of that, negative 1. It opens down. It's going to be below the x-axis then. There's going to be no x-intercepts again. But there's always a y-intercept. Plug in 0 for x, and you get the y-intercept of negative 13. And here's the graph you get. Okay, so negative 2, 0 is the vertex, opens down, stretch factor of 3, so you go over 1, down 3 from both of them. And I can't show you the y-intercept of negative 13 on this because the graph doesn't go that far. Okay. A couple more. How about this one? Y equals 2 times x minus 3 squared minus 1. The vertex from that is 3, negative 1. Y-intercept, plug in 0, and you get 17. Okay? Now, in this one, it opens up, and the vertex is below the x-axis because the y-coordinate is negative 1. So I'm going to have some x-intercepts. You can't really see them from the graph. You can approximate them somewhere between 2 and 3 and 3 and 4. Okay, so with the vertical stretch factor in this being 2, you plot the vertex, and you go over 1 up 2. For the x-intercepts, you got to set y equal to 0 and solve. Easiest way here is to solve from this form, bring the 1 over and solve it, and you get x equal to 3 plus or minus 1 over root 2, which is approximately somewhere in like 3.7 and 2.3 in there. Okay? And the last one is y equals negative x plus 1 squared plus 1. The vertex on that is negative 1, 1. Okay? Y-intercept, negative 3. And we can see that the graph looks roughly like this. Okay? Vertex right there. Y-intercept, negative 3. Because it's negative 4 is the a value, you go over 1, down 4. And the x-intercepts can be evaluated by the same method as the last one. Set it equal to 0 and continue to solve. And you get negative 1.5 and negative 1/2 for the x-intercepts, which looks about right. Negative 1.5 and 1/2. Okay? And that's what you've got there. And that's it for vertex form.